begin with, let me apologize. I'm having some home repair done, and you may hear a saw in the background. I'm just going to keep going. Now, what we'll do here is we're actually going to look at the question you're working on here. You're doing the MCAS 2016 question 33. We're going to actually work with the question, and then you'll be able to answer it. At the end, you'll have the answer. There goes the saw. Can you hear it? Anyway, you recall that our formula for work is W, work, equals force times distance. Recently we saw the formula for power is work divided by time. Now note, we have work here is FD, and we have work here. Now here's the mathematical technique. It's just called substitution. It tends to freak freshmen out though. I don't know why. Watch. We take that FD, that is work, isn't it? We just put it in here, substitute it in here for work. And now we've got another power formula, but it's got more detail, doesn't it? Rather than call work now just W, we're going to call it, when it comes from its equation, force times distance. Now we have three variables in here, and we're going to use this later to solve this problem. Remember this formula. We'll come back to it. Before I do that, I want to show you the technique we're going to use. Let's use an old formula from way back in September. And I've rewritten it here, a little spaced out. See, I have some space here and here. Let's read this. I'm going to mark this up, and you'll see what I'm going to do here. Question is, what happens to velocity if you increase time? There's velocity right there. If I increase time, I'm going to say that means an up arrow here. Okay, I increase time. Now, I increase the bottom. I'm dividing by a larger number, aren't I? Doesn't that mean that velocity goes down? Yes, it does. So we'll just look at the different parts here, read the problem, draw an arrow, and say, oh, the bottom goes up. That means velocity goes down. What about this one? What happens to velocity if you decrease time? Oh, so I'm going to draw a down arrow here. Now, aren't I now dividing by a smaller number? I'm dividing by a smaller number, so that causes velocity to go up, doesn't it? That's the technique we're going to use, but with that detailed power formula we saw a minute ago. All right, so let's go on to that now. Let's look at our question. Here's our question. Let's read it. We're going to look at A, B, then C, then D. A student lifts a weight to a certain height. Which of the following requires the student to do more work? More work. Okay. A, lifting the same weight to a lower height. Now the weight is the force, isn't it? It's the force we're having to exert to lift. So that's not going to change to a lower height. That means work goes down, doesn't it? F times a smaller d. It's not increasing work. Out it goes. Let's try B. Lifting a lighter weight, less force. Same height. What's that going to do? Isn't that also going to reduce work? Smaller f. B is out. How about C? Using more power to lift the same weight, F doesn't change, to a lower height. What happens to work? Again, it goes down, doesn't it? C is out. Well, I sure hope D is the correct answer. Let's see. Using the same power to lift the same weight, that doesn't change, to a greater height. Isn't that it? Doesn't that cause weight to increase? Yes, it does. And that's going to be your answer, isn't it? All right, so what do we do here? We used a formula here. We actually kind of made it more detailed by substituting F and D in here. And then we just looked at it, used the formula, and went through and made these changes to what they suggested, showed it by drawing it, and eventually we found this finally, where that went up, causing that product to go up, or that multiplication, which means that the work went up. That's what we're looking for, right? We're looking for more work, aren't we? There it is. We've got our answer, and our answer is D. Well, let's see. I'm going to give you a video code here. I forgot to do one. Let's say the video code is 478F. There's your code.